Okay, we're going to talk about half-life right now. So half-life is the time required for half of an element or something being broken down to wear away. So basically, the time it takes to go from, like, for example, 100 grams to 50 grams, from 50 grams to 25 grams, so on and so forth. And the point I want to get across is that we've been studying this exponential form here. The half-life formula is really just another form of this. So don't think of it as something separate. Remember, A stands for initial, B stands for the growth or decay rate, and X is your time. So for example, we have this fake element, 100 grams of smithium. The half-life is 30 days. How much remains after 30 days? Okay, after 30 days, that means you started with, let's say we started with 100 grams, and we halved it, right? You got all the way to here, you halved it. So half of 100, you're at 50 grams, right? You traveled this way, this was 30 days. 30 days. All right, let's say after 60 days. 60 days. So again, let's say you started back at the original and you halved it, right? It's been 30 days here. You halved it again. So we halved it. Now we're at a quarter, so 25 grams. All right, so 30 days, 30 days. I think you can start to get the point with these simple examples. But of course, we can't just keep writing it like this, half, 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 half. A quicker way to do that would just be 100 times 1 half to the 1, right? 100 times 1 half squared. So for example, letter C, let's say how much remains after, I don't know, let's do 120 days. 120 days. Well, if we write that kind of as a formula here, so we have 100 is our initial value. We're always halving it, we're decaying, right? Basically, we want to kind of make a proportion here. 120 days is how many half-lives? Well, each half-life is 30 days, right? So 30, 60, 90, 120. So 120 days is actually 4 of these half-lives. So you can write that as kind of like 120 over 30, right? 120 over 30. In other words, the same thing as 100 times 1 half to the 4th power, right? 1 half to the 4th power, because you're basically doing 4 half-lives. So if we do this, 1 half to the 4th power, so 1 to the 4th is 1, 2 to the 4th is 16. So we divide 100 by 16, we're going to get that 6.25 grams. And these were really simple examples just to kind of get you understanding what's going on with our half-life formula. So let's go ahead and write that now. So Y equals, we have our A, which is our initial amounts. Our B, which is our decay factor, is always going to be just 1 half. And our time here, our time is going to be the number of half-lives. So really we can call this kind of like the time weighted over the given half-life. This pen is kind of too thick. So this is your exponent, the time weighted over the given half-life. So for this one, we weighted 120, the given half-life is 30 days, and there's 6.25 grams left after that. All right, so let's try a couple of examples, some trickier examples using this formula. Not tricky, really, but let's try this one. Number 1 here, the half-life of beryllium-7 is 53 days. If you start with 500 milligram sample, how much remains after 10 days? All right, so let's try that. Let's use our formula here, number 1. So 1A, so we have beryllium, Y equals our initial amount. Our A is, let's see, 500 milligrams. 500 milligrams. The decay factor, it's always decaying by half. And here, this exponent, we just have to ask ourselves, how long have we been waiting? How many half-lives? Well, the given half-life is 53 days, and I've only been waiting 10. I've only been waiting 10 days, so 10 out of 53. 10 out of 53. So 10 out of 53 is the ratio. Let's go and calculate this now. So 10 out of 53. 10 out of 53. All right, gives us that. And we're going to now take 0.5, 1 half to that power. So I'm just going to round this to 0.189. 0.189. So just approximately 500 times 1 half to the 0.189. So 0.5 to the 0.189 gives us that. 0.87721, and then we're going to multiply that by 500. So multiply by 500, and we get approximately, and we'll round this off, 438.607 what was that, grams? Milligrams. Okay, that was letter A. Let's do letter B. So 53 days. So y equals 500 times 1/2. This time I've been waiting the full 53 days. 53 out of 53. So we can say this makes a proportion of 1. Perfect. I've waited the exact time for it to take it down to 1/2. So 500 times 1/2 to the 1. It's gone down fully a half. So half of 500, that's just 250 milligrams. Okay, letter C. Let's say y equals, we're waiting 106 days. 500 times 1/2 to the 106 over 53. 106 over 53, well, that is just double, right? That's basically just 2 half-lives. You waited 2 half-lives, so you can simplify that to 500 times 1/2 squared. 500 times 1/2 squared, and you can calculate this, that's 1 over 4, so 1/4. So 1/4 of 500, and that is 125 milligrams. So basically it's just halved again. We've waited 2 half-lives. Halved and then it halved again right here. Part D, let's go ahead and try one a bit more random here. So 365 days. 365 days, y equals, so again we start with 500, it's always halving. And we've waited 365 days out of, and the given half-life is 53. Okay, so we've waited many more half-lives. Let's see how many half-lives we waited here. 365 divided by 53. 6.88679. So we'll round that to right there, 6.887. So equals approximately 500 times 1/2 to the 6.887 half-lives. So we've waited, it's halved itself, 6.887 times approximately. Let's go and do that. 0.5 to the 0.5 to the 6.887. Okay? And we multiply that by 500. So it's had a chance to half itself, many different times. So 4.225 milligrams remaining. So that has gone down quite a bit. It's decaying exponentially.